And presenting today about debugging in WebStorm. Joining me today from Montana, where it's cold and icy and had to scrape out his driveway this morning. Joining me today for insight, commentary, and hopefully some teasing, Carson Gross, creator of the wildly popular and frankly just wild HTMX. Welcome, Carson.
Thank you, Paul. Really happy to be here and happy to talk about some debugging and it's a tool I use an awful lot. So I have a lot of opinions on it.
It's been almost 3 years since you joined me on a PyCharm live stream about HTMX. A lot's happened since then. This morning, I stumbled across some kind of review, 20-minute review of HTMX from Wes Boss and somebody else. Catch us up on HTMX. What is it and how's it doing?
Yeah, so HTMX is a kind of an alternative front-end library for web development, and takes a different approach than sort of what I would call the industry standard front-end libraries like React and Vue and maybe Svelte, in that it really focuses on HTML and making HTML more, I would say, more expressive. So rather than doing a bunch of JavaScript programming, you put some extra attributes in your HTML, and that drives behaviors. I guess the biggest difference between HTMX and those other libraries is that the requests and responses are in HTML format. Whereas if you use React or one of these other JavaScript front-end frameworks, you're typically getting JSON back, and then that's processed on the client side. So I would say probably more lightweight approach to web development. It uses the technical terminology that I tend to use. It's hypermedia oriented, and so it sort of is closer to the original Web 1.0 model in that regard. It's good for some stuff, not as good for some other stuff. If people want to go see the essays page, there's an essay on when hypermedia is a good approach and when it's not. But it's gotten pretty popular. Definitely, like since last July, I remember I was sitting on a ball bucket at a youth baseball the state tournament here in Montana, which was in Bozeman. And I looked at my phone and was like, that can't be right. And it really started blowing up because of coverage from the Primogen and then Fireship Dev. That kind of kicked everything off, and then that made a bunch of other people look at it, and sort of nothing succeeds like success, and so it really took off. Enough so that just with that publicity it made, I think it was number 2 in the JavaScript Rising Stars for front-end frameworks, even though it's a library. It just, very unexpected. I sort of expected, organic linear growth, but had a little bit of an elbow last July, and it's kept going. So a little terrifying, but here we are.
In fact, your point about library is something that Wes Boss and the other guy pointed out on the homepage of HTMX. I encourage everybody to go to the htmx.org site, look at the essays, and read about this. Carson, I feel like you've really synced up with this moment where people are realizing HTML ain't so bad and we can render things on the server, right?
Yeah, I think, we're just better to be lucky than good. Right place, right time. I mean, HTMX has been around in some form for almost a decade now. HTMX is really version 2.0 of intercooler.js. So I think I got kind of lucky. We released our book in July as well, and so sort of all these things just kind of lined up. And then I think React releasing their server components and kind of pushing the focus back on the server at the same time, that was probably good for HTMX because it's an alternative approach to like the same problem. So yeah, I think there's a lot of luck in there. And, I had gotten back on Twitter. I had kind of committed to making a big push on Twitter when we released our book. And that just happened to be right when everyone started looking at HTMX. So a lot of things worked out.
A quick note to WebStorm. Let's remember to push Carson's book. And also all of you, if you're still on Twitter, follow Carson because it's hilarious. I'll just close out on this. Carson, you sometimes describe HTMX as what HTML should have been if they kept developing it.
Yeah. Yeah. I mean, I think HTML, it's a testament to how powerful the ideas of hypermedia are, that all of Web 1.0 was built just with links and forms, which are
Yeah.
two pretty clunky. Those are what are known as hypermedia controls. They're
Yep.
things that are in the media that allow users to select actions. That's kind of the special. That's what makes media hyper. And there's only really two of them. There's, you can talk about like images and iframes and some other things, but really as far as like user experience driven, user interaction driven, I should say, hypermedia controls, those are the only two. And they kind of stopped there because it was good enough to do all of Web 1.0.
Sure.
And Web 1.0, there was a lot there. I mean, a huge amount of value was generated, but they they just stopped developing HTML in terms of it being a hypermedia. And so it was nice. To me anyways, in retrospect, I don't know, kind of stumbled into it, but it seems obvious now in retrospect, something like HTMX, which makes hypermedia controls much more general and powerful, ends up really extending what you can do in HTML. And if they had, I think, sort of taken those ideas, which were there in nascent form, like if you look at links, for example, they can target iframes, but then iframes are sort of a bad experience. And so they were kind of almost there, but not quite. And HTMX and intercooler before that kind of picked up where they had stopped. And I think if you go, people can go check out the examples page on HTMX to see what you can accomplish with sort of the within the hypermedia model, if
Sure.
they just generalize things a little bit. So
count me as one who placed all of his bets on XHTML and Xlink.
Yep.
Didn't work out. Okay, we'll continue. Nope. Today we're going to talk about debugging. Carson, this year I'm pitching the idea of always be debugging, ABD. You did an entire video available on the HTMX essay site about the HTMX source as seen through the Chrome debugger. You are a college teacher. You tell your students that the debugger helps you learn to evaluate the code in your own head. Is that right?
Yeah, that's absolutely right. I'm a big fan of debuggers. And like I said, I'm excited to be here for this talk. I think I tell my students often that learning the debugger in my classes is probably, for most of the students anyways, is probably one of the most valuable skills that I can teach, because what the debugger often gives you is since it gives you a visual representation of what's happening, it teaches you how the code is being evaluated, like what's happening when you can step through the code and actually see it. And there's something very visceral about that I think there's a certain number of developers who don't need that, who kind of like understand code at a sort of organic and intuitive level. But for a lot of developers, and certainly this was the case for me, until I really saw step by step how execution was working, it was really hard for me to build a good mental model of how computing worked. And one of the things I tell my students is what being a good developer means, or at least part of what being a good developer means, is the ability to evaluate or emulate code in your head. So you look at the code and you can understand what it does just by looking at it. And the way to build up that intuition of what the code does is to step through it, or one good way, I should say. It's not the way, but for many people, it's really a light bulb moment when they start working with that tool. You can really blow young students away by showing them a good debugging experience.
You actually stole my line. I was about to promise everyone in chat that I'm going to blow you away with the debugger today. So I will still try to blow you away. But first, let's do some housekeeping, and then we'll jump right into it. Just bring up some slides. We'd like to make this live stream as live and conversational as possible, as you see with the conversation we're having right now. If you have any questions or problems in the live stream, go ahead and let us know now. I'm looking at the comments right now. Hi, Costa Rica. Cool that you're here with us. Dave Williams. HTMX is a part of the show, but debugging is the star of the show. We'll also have a few pauses during the live stream where we'll take questions from the audience. We'll talk about what we just saw, and we will continue. Usually the first question is this being recorded? It's YouTube. Of course it's recorded. And in fact, I've done like 5 trillion live streams, and every time I say this and 30 seconds later, someone in chat says, hey, is this thing being recorded? Hey, Chris Woodruff. Yes, it's being recorded. Don't be the person who asked me in 3 seconds. Apparently someone on Twitter has already asked, and my colleague, Jan Nicholas, just made fun of me by asking. Let's see. We are wrapped up with the housekeeping. We will go ahead and switch over to my screen and jump into the debugger. As I posted very near the top, if you want to follow along on all of this material, let me see if I can peel this off and bring it onto my screen. I have 26 pages of material that you can follow along on that I'll be working through. Okay, we're going to start with how do I set up a debugging run configuration? If you've used WebStorm or any of the IntelliJ IDEs, you will recognize that things run in a run configuration. Things debug in a run debug configuration. It's the same configuration. And I'm going to start by showing running the debugger or debugging using Chrome's debugger. So what I'll do is I have a very simple HTML website that has some code that it's linked to with an event listener. And I'm going to set a breakpoint right here. And I'm going to go back to my HTML. I'm going to right click and I'm going to debug this page in Chrome. When I do, and I will move this over to the side and get these side by side. It launches a private Chrome session so that it doesn't inherit any of your cookies or pollute your blah, 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 blah. This is completely managed by WebStorm using the Chrome DevTools protocol, where the IDE intercepts all the inputs and outputs and displays it over here. So for example, this thing that got imported did a console log. You don't have to leave your editor to do debugging. You don't have to edit, switch over to Chrome DevTools, poke around, come back. We try to bring everything as close as we can to the editor. So we intercept the console logging and display it here. What did it do along the way? It made a run debug configuration. Let's go look at it. So this is the one that it made. It's in italics because it's kind of a transient one. You didn't explicitly say that you want to store it or anything like that. You didn't manually configure it. It is a JavaScript debug run configuration. If you were creating it manually, you would select that. What are we doing? We are telling WebStorm to fire up its local HTTP server, which it manages, and serve up this HTML page and all of its assets. Just as a nice chef's kiss on top, WebStorm has a live reloading server. It will watch for any changes in the HTML as well as any assets that were loaded by that or by something by that. So that is what the run debug configuration looks like when you do a JavaScript debug configuration. Sometimes you'll also see it if you have an NPM script, like I do a lot of 11e development. I go to the package.json script, I click run or I click debug, it does the output, and then it has a URL that I can go to the 11e dev server, and I can, it's like shift control click, hover over it, it tells you what it can do. And it'll launch a JavaScript debug configuration, which is remote controlling the Chrome JavaScript engine. All right, we'll get a lot more into what you can do with debugging on that in a second. What I'd like to show next is that is debugging JavaScript in Chrome What's it like debugging JavaScript in Node.js? Real quick, and then we'll come back and take some questions and talk with Carson about it. So, for example, I have a actions.mjs question to the audience. Why did I call that .mjs? And let's see if anybody gets it right. I can walk up to this JavaScript file, and in fact, I'll stop debugging this, turn that off. I can walk up to this JavaScript file and debug it the same way I did the index.html. When I do so, it debugs. It runs it under the debugger, and I see the console log output. What did it do? It created a Java run debug run configuration, but this time it wasn't JavaScript debug, it's node.js. Look at that, baby. We got a lot more options on this one. But still, they're both behind the same user interface, close to the editor. You learned one way to debug. You've learned debugging in Chrome as well as debugging in Node.js. All right, I will pause there and we will come back on screen and talk about this a little bit. I see that we already have an answer. So if we could get me and Carson back on screen. I see we already have an answer. Carson, did you know the answer for why it was .mjs?
Nope.
All right.
I don't.
Yep. I wanted to be able to use the same source included as a ESM module in a browser as well as in Node.js.
My favorite ESM modules.
I think you're not telling the truth. I think that has caused a lot of pain, and your therapist told you to say that.
Yep.
Yep.
Modules in JavaScript in general are a little insane. But
all right, let me go back through some of the comments. Let's see. A lot of fans of Carson here today. There was a question about providing examples for debugging Node.js. Yes, you will. And this is for Fabian. The last segment that I got to make sure I get to is all about staying in Node. And that is the way I develop front-end stuff. Andre asked if it will work if my application is running inside a Docker container. I will show that in a second when we switch over to HTMX and debugging an example from Carson's HTMX website. Kudos to all of you for getting ECMAScript modules correct. There will be no TypeScript in this presentation. Sorry about that. Not sorry at all. Carson, how many times do you get asked to switch the HTMX source to TypeScript?
A fair amount. A lot of people do kind of copies of HTMX in TypeScript. We recently added what is it? The JavaScript type annotations. JSDoc. We added JSDoc to the code base, which is sort of a halfway step between TypeScript and JavaScript. And when we were all done with all that work, the validation found no additional errors. There were no type errors that came out of it. So, it's good for. I've said this, and if you've ever read the GrugBrain developer website, I talk about my opinion on type systems, which is I think they're good for error checking to an extent. Something like TypeScript is good to an extent, but the real strength of them is in tooling and like editor support. So when you hit dot on something, you can see what you can do. That's the thing that I miss in JavaScript when I'm like in a really gnarly, dynamic environment. Although I do have to say WebStorm does a pretty good job of figuring stuff out, even without, a lot of type annotations. My general belief is that there's an 80-20 rule in play with type systems. And if you try and make type systems too safe and too sound, they end up hurting more than they help. But that's controversial.
And you're not intending HTMX to be shipped as something where people import a function and run it.
No, it's not designed. Exactly. It's not designed. There's actually, what is it? datastar.dev. And the guy who created that came in and wanted to do exactly that with HTMX. HTMX is sort of its own thing. It's an internal complete library. And so it's not really designed. There is an API for it, but the API is more of an afterthought, and it's not designed to be composed in the way a lot of people prefer, particularly in the TypeScript world. And so it's just a different way to build software. I like it. I like it because it means that you don't have to do anything fancy to get HTMX to work in a browser. You can just take that JS file and dump it into a browser, and it works.
Indeed. And in that video you had of walking through the code, you emphasize that.
Yeah.
Okay, let's proceed on to the next, actually see some debugging in action. So back to my screen, and we will, for the next couple of steps, we'll use debugging in Chrome, which is risky for me because that ain't the way I do it. I stay in Node.js with a fake web browser called HappyDOM. So let's see if I make it through this alive. What I'm going to do is set a breakpoint to stop execution of the code so I can poke around. Carson was talking backstage about this. Debugging isn't just when you have a problem. It's also when you just want to poke around, learn, experiment, see what's going on at a moment in time in your code. So in this event listener, I have set a breakpoint. I went to the line, I went to the gutter in the line, and I set a breakpoint. So that now I'll bring back up the JavaScript debug run configuration. And I sure hope this is the right one because I got multiple Chromes running. If I click on it, I've got the click handler for that div, and it executed this anonymous function and stopped on this line. Now remember, the code's executing over in Chrome, but I'm sitting over here. And I get to take advantage of all the benefits I have of being debugging close to the IDE instead of Chrome DevTools. I'm where I'm editing. I'm where I have all of this massive tooling for navigating my code, refactoring my code, all that other kind of stuff. And I get to poke around and see what are the values, like what is the inner text of the sum that I'm about to replace. So all of these things with the breakpoints work here, and I can click resume to continue. So I was able to inspect the values, the normal breakpoint stuff. But again, executing in Chrome. One thing that's kind of cool is I can close this and trigger the debugger again. I've got more screen real estate, but WebStorm is giving me these pseudo comment things at the end that are telling me values of my state at different points in the program. If there was a value passed in as an argument, like I could have put EVT on there and we could have inspected EVT there. Later, you'll say, hey, wait, there's a lot more we can do with that. We'll get back to that. So this is actually a mode that I use quite a lot to get more screen real estate is I just hide the debugger window when it comes up. And if you do that, though, you need to know what is the key binding for resume so that you don't have to open it in order to resume or step into your code, step through your code, blah, 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 blah. So that is the minimum of working with breakpoints. And again, I just want to emphasize this point. Yeah, what I just showed you, you can do in Chrome DevTools, but it's nice to be able to stay in the IDE where you've already learned a lot of these coping mechanisms like navigating your code, but more importantly, where you are doing your editing. I will pause here for a second. Look over for some questions. And Carson, I don't think this is necessarily the way you work. I think you use the Chrome DevTools directly. But do you want to comment at all about switching between tools?
I use both. I'll use the Chrome debugger. Often I'll use the Chrome debugger if I'm kind of like caught out in the middle of something just because it's there. But I also use the debugger, particularly when I'm debugging tests. because of exactly what you said. It's nice to have all the context and being able to navigate around in the code. The Chrome environment is a pretty good debugging environment, but it's not an editing environment. You can't change anything in it, and so it's just it suffers in that regard. Could I actually ask you to go back to that breakpoint, because there's something I want to point out there. I don't know.
Sure.
If
When
you
we
were
come
gonna
back on screen, I'll answer some questions. When
Okay.
we come back on screen, we'll point that out. Is that all right?
Yeah, absolutely. There's just
All right,
something I
cool.
want to point out about
Okay,
it.
so to go through a couple of things from chat, Rudolph, I'm going to show a back end. It's just not the one you want. It's going to be 11, which really isn't a back end, but it is a big Node.js application. So it's kind of going to be the same thing. And then let's see. There's a comment about which browsers to use. Let's see. Conditional, Michael, you asked about conditional breakpoints. The star of the show, that's coming up next. It might actually be what Carson is referring to right now. Definitely Angular debugging and WebStorm is a big thing. You're about to get Jan Nicholas to, he has already replied to you, and you're going to get so many messages from him. You're going to do a cease and desist order. Let's see. Okay. Code find about JSR instead of Node for running JS debugging. I'll let Jan Nicholas handle that. Let's go back to my screen. And Carson, what do you got? You want me to
Just get that. No. Just click on the browser so it comes back to that breakpoint. I want to talk about something real quick. Okay. So if you look down at the bottom in that the actual debugging window, where it's saying you can see local and unknown and global down there. I just wanted to talk about what that is. That's basically the stack, or those are the scopes that are in scope. And JavaScript has pretty crazy scoping rules. But what's really nice about this is if you open up unknown,
Carson, I'm going to give you a better example.
Okay.
What I'll do is I'll set let's see, I'll go to here and set something way down in. And now when we stop, you get a lot more.
Yeah. Okay. Perfect. So basically, all I wanted to talk about were the two windows in the bottom and then the bottom left. And so the window in the bottom that has all these like names with symbols associated with them. Those are the scopes for JavaScript. And this is what I mean when I say the debugger helps you build up a better mental model. Like if you don't know how JavaScript scoping works, this window is giving you a really good visual presentation of that. And so it helps you develop an intuition of like, where is I coming from? Where did I come from? And especially in Java where you have a bunch of closures and callbacks and so on and so forth, it can be kind of hard to tease out exactly where these symbols come from. And so this nice visual representation helps you to start develop that intuition for JavaScript that can be difficult without that, and then similarly on the left side there, that kind of stack of names that are the function names down on the bottom, just right next to the scope window, where we've got anonymous, increase sum, and sum random. What that's showing is that's a call stack. And call stack is something that a lot of newer developers don't really understand. They understand, I can call a function, but they don't get this idea that there's actually a stack of functions. There's people like when you make calls, they stack up on top of each other. And so this, for me in particular, in the IntelliJ editor, was really a big deal for me understanding how computers worked and how function calls like actually truly worked, to like develop an intuition for like what a stack is and so forth. And so I think, obviously like if you've been programming for a long time, that's super intuitive to you, but for younger developers and for my students, I think this is a really crucial teaching tool for them to show them, hey, when we talk about, because I teach a class that goes basically from transistors all the way up to like virtual machines. And part of that transition is, okay, here's how function calls work at the assembly level, but now here's how they work in C. But hold on, let's look at it in CLion, the JetBrains C editor, and like you can see the actual stack, and you can look at the memory addresses and see what their values are and so forth. And just the ability to see that really, I think, opens up younger developers' minds as to like exactly what's going on with the machine and helps them develop that sort of ability to emulate code that we've been talking about.
let's make a statement for older developers' minds. Exactly what you're saying right now. And Walter, you made a point about this thing about scopes is a great thing to discuss. For me, when I'm doing JavaScript development and I've got a framework that's calling me, and I'm like, how the hell, what was the code path to get here? You'll never figure it out by reading the source code, right, Carson?
Yep.
But what I can do is set this breakpoint in my code and go look and say, oh, that's the thing that called me, and that's the value it called me with.
Yep.
And if it's in the middle of some humongous branching code of mystery, I can then set a breakpoint up there and watch its path before it calls me to see what decision it made in order to send me what values. Carson, you want to add anything to that?
Yeah, I think that that's sort of that dynamic exploration of code bases is very underrated to understand, because you do need to understand these frameworks that are calling your code. You do need to understand what are they doing, and that's one of the things in that video you mentioned earlier. I try to do is show people how to debug HTMX so that they can understand how is this working. And the debugger is just a crucial tool there. Like one thing I'll often do when I go into a new code base is I'll try to find like 5 or 6 important looking tests and then start them in debug mode and like step through them, or set a breakpoint somewhere in the code that I know gets hit and let it run to that point, and then look like, what's the stack look like? How does this work? Because that's going to give you a much stronger picture of what the code base is actually doing than, for example, ER diagrams or whatever, some sort of diagram approach. It just gives you a much more dynamic and deep understanding of how the code is working, versus looking at pictures or whatever, documentation or whatever it is.
I'm going to be pushing today, always be debugging, always debug. Don't run your code, debug it, so that the moment when you want to reach for the, wow, I'm confused, you don't need to switch to the debugger. You're already in the debugger. Always be debugging. It's so fast now that you might as well do that so that you take advantage of what Carson was just saying. Let me do a couple more things about breakpoints, and then we'll come back to taking some questions. I'm in the middle of a loop, and maybe what I'm doing is different when I'm on one particular value versus another, and I don't want to have to say step, 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 step. So let's talk about stepping real quick, and then let's talk about conditional breakpoints. If I've got a breakpoint here, I've got breakpoints in other places, and I want to get rid of them. Where are those other places? We have view breakpoints, which brings up a listing of the places you have your other breakpoints. And you can turn them off temporarily, or you can delete them. So for example, if I had a breakpoint here and I had a breakpoint here, and really I'm only focused on this code right now, I can go back and turn those off, or even better, delete them. And now I'm focused on that one thing. As an aside, this is the breakpoints editing window, and you see it's got a lot of cool stuff in it, like logging in the breakpoint in the debugger instead of putting console log statements in. Go to your favorite website, open the JavaScript debug console, and see all the console log statements they accidentally checked into version control. All right, with that in mind, if I go through this, I'm like, okay, this really sucks. So instead, what I would do is I'll stop debugging and I'll go right click on my breakpoint, and I'll set a condition that says, hey, could you just go through this until we get to 3? And now when I debug, I see that I'm now greater than 3. I is greater than 3. It's 4. And conditional breakpoints can really help you speed up your debugging. So additionally, I want to talk real quick about stepping. I'm in the middle of a loop. What I really want to do is go look at this calculation stuff like get multiplier. So what I want to do is step through my code. I could step over my code and it will go to the next part of the loop. But if I'm on a line and I want to go into what that line is executing, I want to step into it. Now, what's interesting is WebStorm has smart step into. There are 2 statements on this line, and it's like, hey, which one do you want? So I can step into that one. I'll say step over because that wasn't that interesting, and I'll keep going. So that is stepping. Sometimes, though, what I really want to do is like, oh, dude, could you just run to here? Well, I could set a breakpoint, but breakpoints are forever. And then I get this whole breakpoint explosion and stuff like that. Well, if this is just a one-off, I just put my cursor there and I do run to cursor. To tell the truth, I don't know if that button is in WebStorm by default because I put it there a long time ago. You may have to go and edit your toolbar to get that in.
You can also right click on that line, I think, and say run to cursor.
Hey, even better.
I do that. Yeah. Run to
Or you
cursor.
can memorize that crazy thing. On my keyboard, F9 is a painful operation. So what I do is I'm like Carson was talking about, I've got the code execution in my head. That's something Carson said at the very beginning. And I'm looking at this line and I'm like, that's the place I want to be. Run to here and stop. And now I can walk through this and be like, what is I? Oh, I is less than 10. So that's the code path. Okay, I will pause here. We'll come back on screen. Carson, do you have any commentary you want to give on that part about techniques for debugging and walking through code?
Yeah, no, I think that was really good. The run to cursor and also force run to cursor if you want to ignore any breakpoints that might be between where the
Good
current
one.
execution is. That's
Good one.
so force run to cursor is often a good idea if you just want to ignore all the other breakpoints. The other thing when we go back to the code, I'd like to go and look at that first method that you stepped into and just make a point. Just make a point about the code, which is one thing. I'll briefly describe it here, but I think there's a way to write code that's debug oriented. It's not necessarily the way you would write things naturally, but it makes your life easier when you want to do debugging.
Thank you for doing that because I wrote this for demo purposes. I put things like I could have done a ternary, but then stopping on the correct line is a little bit more complicated. Walter asks, does WebStorm support stepping in JS? We just showed it. We showed different ways to run forward and backwards. We showed how to go back up the stack a little bit. There's also kind of like run backwards to something that kind of goes back to a point in time and shows you what the values were at that point. Let's see. I believe most of these questions are good. So thank you, Jan Nicholas, for covering it. Let's go back to the screen and let's cover what Carson was just talking about.
Yeah, just in that get random method. Let's just look at that really quick. So this is a method that it's not a bad method. It's fine. It's just doing some mathematics, and it was just, again, some demo code that was written. But the thing to notice about this expression, so we have this return and then we have an expression afterwards, right? This big expression with all this stuff going on. That's what's known as, that's a complicated expression. So there's a lot of stuff going on inside of it. And so if you wanted to make this like more debuggable, so the first thing you could do is exactly that. You could extract that to a local variable and then return just that variable. But then also you could break this expression up. So you could, for example, move the math.random multiplied by multiplier out to its own variable. And a lot of developers would view that as inefficient, and it's at some level they're correct. Although, typically computers are so fast now that stuff like this isn't something you're going to notice. But as you do that, it actually becomes easier to debug. So if you reduce the complexity of your expressions and declare more variables, and then when you have return points, if you try and have as few as possible returns and maybe just one return at the end is a common like ideal to sort of shoot for. And then it's returning a single variable. What that gives you is it gives you a lot of places to set breakpoints in your code. So you can set a breakpoint at a particular spot, and you can see exactly how the computation is going on. Now that's different. I'm as guilty as anyone. Like I use ternary operators. I get these crazy complicated expressions with like, multiple ands and ors and parentheses and so on and so forth. I'm as guilty as anyone of that because you're just trying to express it all in one line. But as you debug more and more, what you'll notice is if you're a little bit more methodical and plotting and maybe take a little bit more space to define variables, it's actually a better debugging experience. And ultimately, I think it ends up being more readable in the long run. But it is more code. You end up with more lines of code. So that's the trade-off. But it's just a different way of structuring your code in order to be debug friendly.
Well said. And as you kind of hinted at, the bundler is going to write something completely different. And certainly the just-in-time compiler is going to do something radically different. Why don't you just focus on what makes you the fastest and puts a smile on your face?
Yep.
Optimize for your own productivity. Okay, let's do a couple more things and get over to Carson's code. We are stopped at this line. Maybe we want to poke around. We're not debugging. We want to poke around. Maybe I want to see, is set length, I get autocomplete. Is it less than some? And I get autocomplete there too. And I see the result. So what I'm doing is I'm letting WebStorm's kind of evaluate expression panel here in the debug window let me poke around. And I get a lot of the tooling help that you see there, and it's all in a GUI. But if you're a console kind of person, you could also come over here, and we will also give you autocomplete there as well. You can see stuff. And in fact, if I say something like x, y, z equals 2, I think if I go back to here, because I didn't do it over here, so it doesn't know the scope. So this is a way to evaluate expressions, but what you may wind up doing is you evaluate the expression, you get the answer you want, but you need to change your code and re-debug. Then you got to type that expression in. It's true that we will have it in the dropdown for you, but you can also set what's called a watch. And a watch is a computation that you want to, wait for it, watch. So I'm going to add this to my watches. And if I rerun the debugger, it will stop on that line. And as I like resume, it keeps showing me the update, the updated expression. And that's really cool. Watches are really cool. They're easy to manage. I can go in and remove this watch, remove all the watches, edit watches. If you like this kind of mode to get more screen real estate, you can walk up to this and you can add it as a watch. You can put the expression back in. And it's sitting there right beside your code. And as you're stepping through things and rerunning your program and stuff like that, it's telling you the answer on this line. And we save it in all of our settings so that when you run WebStorm again, it's still sitting there. And if you hate it, you click the X to get rid of it. Okay, with that in mind, let's see, I've done stepping, I've done run to cursor. We'll come back on screen real quick and get any points from Carson, as well as take a look at any comments that come in. Carson, do you do watches?
I tend not to do watches too much. I use them like occasionally, but I mean they're super useful when you need them. But again, since I've started to, as I've gotten older, I've tended towards sort of this more debug oriented code with lots of what someone in the chat called explanatory variables.
Explanatory variables, yeah.
Those tend to take the place, because when I find myself needing a watch, it's because I have a complicated expression that I haven't declared as a variable. And so that, I think that's when you end up leaning on them more. So if you get, maybe you don't control the source or something like that, or maybe it's just, you've got a big complicated expression and you're not going to refactor it into something simpler, then at that point, that's when I would typically lean on a watch.
Yeah. And in fact, Someone in chat used the exact same point.
Yeah, that's where I had never seen that term, but explanatory variables I think is a good one.
Yeah.
I did see someone talking about like stepping backwards. Are you
Yeah.
going to talk about? Are you going to talk about dropping frames and that stuff? Did you
I'm
mention
not
that?
going to, because I got to get to your
Okay.
code.
Okay.
So yeah, Nicholas, if you could go find WebStorm help and talk about going backwards in code and
Yeah.
paste the link, I would appreciate it.
Yeah. There's
Really
a
quick.
feature.
Oh,
Sorry.
sorry. Go
Go
ahead.
ahead. Oh, there's a feature called drop frame. You can drop frames. So you can't step backwards by one, as far as I'm aware. I don't know exactly how the JS debugger works, but you can sort of restart a function. And then you can also drop like a call frame down to like the method they called it. So you go back in that regard. This is one area where Paul, I mentioned to you, the Visual Basic 6 debugger back in the 1990s was unbelievable in that regard. You could grab the program counter and put it wherever you wanted. So it was pretty magical.
I think my friend and colleague Khalid Abahakma is about to put out a hot take meme about VB6. I dare you, with Carson's picture on it. I dare you, Khalid. Okay, let's switch over to HTMX at long last. So back to my screen. What we'll do is I will go to the example that Carson has. I'm not going to put it on the screen because I've got it right here. It is a JavaScript debug run configuration of this URL. Now, what's cool about this is it's not on my local computer. All the resources are over there, and I'm going to debug them anyway. At the beginning of the live stream, somebody asked, hey, how would this work in a Docker container or in a Java Spring Pet Clinic thingy? It would work like this. So what we will do is we will debug this, and I'll put this to the side at some point. I got to close some Chrome sessions. And I'll hide all of you folks because you are all meaningless. I'm not going to comment on the favicon. That's not my department. You'll have to go to the manager. And what I'll do is the first thing I need to do is, so we have a JavaScript run debug configuration. I ran it under the debugger. It brings up Chrome and remote controls it. So I can sit over here in the IDE, but I don't have the file. Where's the file? If I could only go to the Elements tab, oh, look, maybe it's there. Maybe it's there. And in fact, it's there. So I can go in the demo and I will go to line 86. And this is getting into HTMX programming. HTMX is going to run this code when a get happens because it's registered itself into the page. And I can set a breakpoint and I don't have to know the code path to get here. And then I can see, how did HTMX call me? What did it call me with? And what mistake am I about to make? So I come down here and I click to edit. Here's a test for all of you out there. What's going to happen when I click to edit? If you said WebStorm's going to stop at that breakpoint, you are correct. It gets to there, it stops, and lets me poke around. I can see what's in the request. I can browse all of this stuff. I can write expressions to see if I'm getting the data that I thought I would get. I could look in the DOM. I mean, I've got the document. I could do query selector and go grab a node and see if it's got what I think it is. Carson, do you want to comment on normal patterns in HTMX development for what data is handed to a function?
Yeah, so this is on for all the demos that are on the HTMX website. We use a mock server to avoid having to set up and pay for
It's spelled
you know,
that, right?
yeah, Synon.js, exactly.
I didn't pronounce it,
Signing
so I don't know how to pronounce it.
Yeah. So this is helper code that we wrote to make it a little bit easier to work with that mock server. And so what we're seeing here is HTMX has made a an Ajax request and Sinon has mocked that out and has passed it on to this handler. So this is simulating effectively a server side handler. And it just does some, basic stuff to create a body and then passes that body back to the to HTMX. So you can look at the stack down there on the left. It's pretty complicated. A lot of JavaScript libraries get pretty crazy with their stacks. And I think it's actually, unfortunately, async as well. So we probably can't see HTMX in the code in that stack trace because it's probably waiting on a promise or something like that somewhere. But if you set a breakpoint over in HTMX.js, which was in that original elements window, in there, if you went down to, I don't know if this might take a little bit. This is pretty big. Someone asked in the chat if this works with minimized code, and it does, but it's not great. Because minimized code can be so gnarly. But if you're able to set a breakpoint in here, and I think it might be just downloading. But this is one reason why I say it's often a good idea to not ship minified JavaScript. So minimization is something that we've done sort of as front-end developers forever. And I think it really hurts debuggability and explorability of code. It hurts the visibility because minimized code is so hard to read and understand. And yeah, there are source maps and all that sort of stuff, but it never quite works the way you want it to. And if you ship unminimized code, but then use compression, you actually get a pretty good savings. You actually bring the size of the reason we're doing minimization is in order to make the files smaller. That's the only reason we do it. And so if you actually use good compression algorithms, you can get most of that and not ship this code that's been completely munged up, and makes it much easier to debug. And so that's one thing I've started. I don't know, did DHH say that? I think he's on that kick too. Like maybe we should
along with
JavaScript.
a stop bundling.
Yeah, exactly.
Stop minifying, stop bundling.
Yeah, exactly. And I think this speaks to this idea of like computers are fast enough now, networks are fast enough now. This stuff is all cached.
And HTTP3 are pervasive enough, so you don't get
these things are cached after the first request. They're relatively small when compared with images and all the other junk that's coming down with the website anyways. So maybe the right thing to do to increase the explorability and debuggability of the web is to stop doing minimization and just start shipping unminimized JavaScript. Still compress it, of course. You don't want to just have it shipped in plain text. But that gives you most of the benefit without the downsides of making things very hard to debug.
All right, I'm going to switch over, Carson, to the next thing, which is what if you are a contributor to HTMX and you want to use the debugger as if you were Carson. So in Carson's HTMX repository, he has a README with instructions about running the test suite. So the first thing you do is you go to the terminal. If Carson had this in his package JSON, I wouldn't have to do this, but npx serve fires up a server. In theory, I don't have to do this either. I could just use the JavaScript debug, hot reloading server, stuff like that. But I want to inherit all the pathing that Carson may or may not have done. So with that in place, I can now go to some of his code. For example, his Ajax code, which is at this path. I'm looking at this test, and I want to debug this test. How would I do that? I'm going to go to the index.html of his test directory, and I'm going to debug it. It's going to fire up Mocha, hundreds of tests, and it's going to stop on this line. And I'm going to step over it. I'm going to click a button. And then I'm going to go see this button.enter HTML. Is that really what it is? I want to see the outer HTML just to see the whole thing that got clicked. Oh, okay. It's got an hx.get on it of that path. That's what I was expecting. This test does what I think. So this is an example of using debugging to walk up to someone else's code and find the path to how it got there. Carson, want to comment on this?
Yeah, I think this is a great way to learn how HTMX works. Like, go through the tests. First of all, the tests will sort of show you what all the features do, and then what you can do is set a breakpoint over in HTMX.js in like the I think it's issue request function, which is kind of big and hairy. And
Do you want me to do
then as
that,
you
or are you just speaking through it?
no, you can, yeah, if you want to do it, it's fine. It's all good.
Okay, so
It's
where's this going to be?
It's going to be under source, under SRC there. If you
I
open
could
that
just
up and
navigate
then,
in
yeah,
here.
HTMX.js, yep. And then search for issue request. Keep going. I think it's, keep going. Sorry. I don't have it up in front of me. Keep going. Oh, issue Ajax request. Sorry, issue Ajax request.
Okay, I'll go to the definition of this.
Yeah, navigate to that guy. And just set a breakpoint like there-ish. And then rerun this test. And see if it stops there. It should stop there when you click. If it's using the right one. I always forget which one it's using.
I think it finished the test frame, so
okay. It might not have hit that breakpoint.
Okay.
Syntax errors. I don't know what's going on there.
Don't worry about it. I think this is actually intentional stuff, and we are reporting things that you expected.
Yeah.
Exception.
Yep. Yeah.
Okay, so go ahead. Finish with your
So when you have this set up and running, what'll happen is that button will get clicked and then it'll break over in the HTMX code.
Right.
And you can see, okay, like this got triggered by an event handler that was hooked in earlier. You can see where that all happened. And then you can step through and follow to the point where it issues that Ajax request.
Yeah.
Again, that's just a great way, I think, in general, to explore any new code base, is to find here's some interesting looking functions, set a breakpoint in it, and then go and find some tests that look like they're related to that and run them in debug mode. And then you can see what the call stack is and how everything's laid out. And that again really builds that intuition in a dynamic way, that just looking at the code, staring at the code. One thing I tell my students is don't stare at code. It's okay to stare at code a little bit. We all stare at code a little bit, but you want to be in the debugger and seeing the dynamics, because just staring at the code, it can be difficult to discern what the dynamics are, whereas the debugger will show you exactly how the function's being used.
And for me, the best part is it will show you how it was called, because it may not be clear to you how we got here.
Yeah, exactly. That dynamic context.
Yeah.
Like, okay, I can see what this function does. Maybe I can figure it out just by looking at it, but how is it used? What arguments are passed to it at runtime? Like what's the actual behavior of it in this system? And again, the debugger, there's nothing better in my mind for most people than the debugger to give you that context. You can do logging. Yeah, you can do logging, and that helps to an extent, but I think those are complementary technologies. Yeah. And so
let me finish up with this last section and then we will get out of here. This is, instead of being browser based, this is a Node.js application. It happens to be 11D. And for our JetBrains guide, we have an 11D that we added TypeScript and TSX and Vite and VTest and schema validation, all kinds of stuff, but it lets us do component driven development. So it's a little bit different than the library that Carson has for HTMX. This is individual units which are exported and can be executed by themselves. So this looks like a React. And so this is a lot like a React or an Angular or a whatever style of component driven development. This is the way I develop. I don't ever go to a browser. I stay in my tool. And when I execute in Node.js. I execute in Node.js with a fake browser called HappyDom. And most importantly, I execute under the debugger, because always be debugging. So I've got some code over here on the left, which I want to poke around on. Like, okay, What did you pass me, 11D? What were the props? Who called me? And then I'll go over to my tests and I'll walk up to a single test and I'll say, debug you. And Vite fires up, and V-test is pretty fast. And so it ran and it stopped right there. And I can see what were the values that were passed in here. And I can step through the code and all that other kind of stuff that we've already been talking. I never click run. I always click debug because it's so fast. And I can look up and see who called me and all that other kind of stuff. As it turns out, that was only kind of fast. There's the really fast, which is run vtest under watch mode. Oh, that's the wrong one. That's running the site. Run all tests under the debugger. Fires up vtest in watch mode. It runs all of our 100 and blah, 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 blah tests. How many tests do we have these days? Yeah, and it hits the breakpoint. Go over it. All right, and so I'm sitting in this part with all of my tests, 130 pass, and I'm like, everyone watch. I'm about to hit save. Save. Oh, wow, I broke something. Oh, wow, I fixed something. Here's the way I actually develop. I'm like, I wonder what's happening over here. I'm already in the debugger. It's already running. I do this. Space save. And then I stop right there and I can poke around. I'm not fixing a bug. I'm just looking around. And that's how fast the feedback loop is. Oh, okay, I'm good. Continue running. All my tests pass. I can even hide this. And everyone out there that is thinking, what can WebStorm do for me? This is a cool thing. My test fails, but I don't need to go to the debugger window because it's all right there. I could put, and then I can make it pass, and the squiggle goes away and it changes. More specifically, I could say expect 1, 2 equal 2. Save. And it fails right there. And look at that little window that tells me exactly what the problem is. And I fix it. And everything is happy again in the universe. This is debugging. This is always be debugging, but it's combined with testing. It's combined with component-driven development, so I can look at small little units and do a mashup of developing and debugging. I will stop here. We'll go back to the screen. Carson, any comments on the parts that I just showed?
Yeah, I think that you're showing that dynamic, the dynamic feedback sort of like flow that you can get into when you've got a good debugger and a hot reloading system. This is something, you know, I use JetBrains for a lot of stuff for my Java programming. And one of the things that Java has suffered under is that when you're in debug mode, something called hot swap, which is where it reloads code, it only works some of the time. And so if you actually change the shape of a class, it breaks. And there was an old project that made hot swap work everywhere by Thomas. Shoot, I forgot his last name. But I know that JetBrains puts out a JVM that actually has ported that code to the modern JVMs, and it's called the JetBrains runtime. And I think that you guys should be advertising that more, because when people, if Java developers or JVM based developers can get that working locally, you can set up this environment where you're debugging and you're editing code and you're reloading, hot reloading automatically without any break of like bringing the server down, bring it back up, navigate back to the old spot and restart. And that there's these aspects of dynamic programming that the statically typed languages have sort of set aside as being too hard or not important. And I really think there's an opportunity there for people to bring those two worlds together, to take the best aspects of the dynamic language world where you have this hot reload, everything just hit refresh and it works. And then combine that with, the static typing and the tooling really around the type system that you have available in languages like Java and C# and so forth. So melding those two together with a good developer, debug, and testing experience, if you could bring all those things together, I think you'd really have a really sweet environment.
It's a good point. It's interesting that it was JavaScript that really brought hot module reloading to the mainstream.
Yeah.
And you're right. Believe it or not, JetBrains has Open JDK people on staff, and we have our own Open JDK stuff that we ship. So yeah, you're right. I'll pass that along about us doing JBR. Let's go ahead and bring Carson back on screen, and we'll go ahead and start the wrap up. I know there's a number of comments that I didn't get back to. I apologize, mostly because Jan Nicholas was giving better answers than I would. Dave Williams, you're right. There could be a lot more that we could cover about debugging in special scenarios like Google Cloud, AWS, and stuff like that. And so we'll take that to heart. We'll go ahead and do the wrap up. That's kind of it on how debugging can impact your workflow. Carson, let's come back to your video and your experience and your teaching experience. Any closing thoughts on debugging?
Yeah, I just, again, I recommend people learn the debugger, whatever debugger is available. If all you've got is the Chrome debugger, you can learn that too. But JetBrains, I think, has best in class debuggers in my experience. So learning that, not being afraid to use it, just looking at what all the knobs and tools are and figuring out what they're useful for, because they all can be useful in various contexts and help you build up that ability to execute code in your head, understand develop a mental model for how the software is working and so forth. And then also just, I think we've been doing a lot of JavaScript work, but I think the other languages, the JVM based languages, these statically typed languages could learn a lot from the development workflow that has come out of these dynamic languages. I used to program in Ruby, for example, and Ruby had that same hit refresh and see the code right there. And so I think that there's an opportunity in the industry right now to sort of meld those two together and try and make that developer experience. Probably small talk people are pulling their hair out at this point, if they have any left, saying, we had this back in the 70s and the 80s. And that's true to an extent. There were some really neat development environments of it. Like I talked about VB6. I think you could go back and
very true.
We can learn some stuff from those older environments and what people were able to do in them.
Where state and code were all part of an image that could be persisted, right?
Yeah, just that not breaking developer flow. I think that, again, I hate to keep harping on Java, but I think a lot of Java developers are just used to, I want to change something. I have to bring my server down and then restart it and then go back to where I was. It doesn't have to be that way.
Yep.
The work's already been done. It's just a matter of getting that technology out there for people.
Before wrapping up, Carson, what's next for you and for HTMX?
HTMX 2.0 hopefully be out at the end of the month. It's not going to be a big change from HTMX 1, so we're hoping it's not a big upgrade. I run that project differently than a lot of other JavaScript projects. I try not to rewrite the world, change the API too much. Then this summer, I'd like to put in a lot of work on HyperScript, which is the scripting language kind of sibling project that is more of a passion project alongside HTMX.
I highly recommend all of you take a look at HyperScript as well as HTMX and Carson's theory of locality of behavior.
Yeah.
Okay, let's bring the slides back up and get out of here. All right. If you'd like to get more information on WebStorm, I hope you do, because we just showed a lot and there's still a lot left to show. Please go to our website at www.jetbrains.com/WebStorm. If you haven't already, check out our WebStorm blog, where you can find up-to-date information about WebStorm releases and events such as this. Just saying, we're in the middle of release time. Lots of good stuff going out. Now's a good time to pay attention to all of it. We'd love your feedback on this live stream, so please contact us on Twitter. Can I say? I'm still going to say Twitter. If you contact me on, if you contact Carson on Twitter, you'll get a reply. You contact me on Twitter, you'll have to go to Mastodon to find me because I don't pay attention to Twitter very much anymore. But
I'm actually
WebStorm
not
will,
on. I'm not on Twitter right now. I'm taking a
all
break
right.
until the end of March.
All right. I know you're on Mastodon as well. But WebStorm is certainly there. And if you want to say something about that, Paul just didn't show the thing I expected, they will actually reply and they will make me reply to you as well. So check out what we have. Please let us know in the after webinar survey. If you register for the live stream, you'll get the survey. And we actually read that and try and learn and get better. That's all from us today. Carson, thanks, man.
Hey, thanks for having me on. That was fun.
Thanks for joining us to talk about debugging, for talking about HTMX, but also just sharing the things that you talk about in your class when you're teaching programming. And thanks to all of you for joining us. Hope you have a nice rest of the day.